Now, we're covering the last part of 9.7 that we're going to cover. And that's going to be dealing with law of cosines. Law of cosines is the last one we're going to look at. We're not going to look at law of tangents, mainly because anything we can do with law of tangents, we can actually do with law of cosines. And law of tangents actually involves us using systems of equations because we have to solve for two things at once. So it makes it a little more challenging. Now, law of cosines has three basic versions to find the missing sides. We have that a squared is equal to b squared plus c squared minus 2bc cosine of a. Or that b squared is equal to a squared plus c squared minus 2ac cosine of b. Or that c squared is equal to a squared plus b squared minus 2ab cosine of c. And no matter which side we're solving for, if we notice, it's only contained on the one side. So for here, which one we're solving, A, B, or C, that's the only side it's on. All the rest of the side lengths in each one of the equations are the other two sides. And then we have the angle. Now, law of cosines is really useful if we're given side angle and a side length and angle and a side, where the angle is in the middle, or side, side, side. Because if we're given one of these two setups, we can't actually use law of cosine or law of sines. We have to use law of cosines. Now, to kind of visualize that, if we're given a triangle and told that this is 30, 8, and 7, A, B, C. And we look at the three examples for law of sines, because it's A over sine of A. But we don't know what side length A is. But it's going to be over sine of 30 degrees, because we do have the angle opposite A for this setup. We know that B is 7, but I don't have angle B, and we don't have angle C, but we do have side length C. Now, if we look at these three equations here, in all three, we're missing a unit. Because for the first one, we're missing a length, and for the other two, we're missing a side. In none of these three do we have one that's completely filled out. So we can't use law of sines for this, given side, angle, side. And with side, 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 it would just mean that the top three would have a value, but none of the bottoms, which, again, is the same issue, because we would have two variables we would have to solve for at the same time. So law of cosines is good if we're given two sides and an angle in the middle, or three sides. Then we can find the missing information. So once we start using this, you'll see that this is almost a little bit easier to use than law of sines. Now, looking at this first problem here, we do have a missing side B, and we're missing two angles. Well, if we have two angles in a triangle, we can find the third, because any three angles in a triangle do add up to be 180. So let's find side length B first. Well, according to the equation, B squared is equal to A squared plus C squared minus 2AC cosine of B. Because that's just the general equation for, it's 2 times AC, so the side lengths. So AC are just our side lengths, and B is our side length. And the capital B is our angle, because our capital letters will always be the angles. And the side we're looking for will always be on itself, and then the other side lengths inside the equation are going to be the other two sides. So since we're finding B, we can leave it as B squared is equal to, well, A, we can say 11 or 14 at this point, but A is normally going to be 11 because it's opposite side length A. C is going to be 14, minus 2 times 11 times 14 times cosine of angle B, which is 34. AC. yes, and yes. But I wouldn't type it all in quite yet. Let me get a highlighter. Because for the most part, when we type in cosine or sine of an angle, have we gotten really nice numbers? No. There's been a few cases where we can, and that's where you're either going to get 1, -1, 0, or a half. We can get those are nice numbers, but the majority of the rest are not nice. And have we gotten b completely by itself? Well, no, it's the square b squared. We really don't care what b squared's value is. We want to know what the value of b is. So what we're going to have to do still is square root both sides. So we could have calculated what 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34 is, and got that value, then approximated it to get the square root of it, and then find the approximate answer. But if we do that, we're rounding twice to be able to try to get it. So instead of doing that, what we do and get is more precise answer by just typing it in as the square root of 11 squared plus 14 squared minus 2 times 11 times 14 cosine of 34. We can just type it all in with the square root. So we don't have to do each individual step. So if we get the calculator, we can go second square root of 11 squared plus 14 squared minus 2 times 11 times 14 cosine of 34. And hit enter. And we can just type the whole thing in with the radical. Yes. Yeah, so to finish this off, it would be 7.9 because we're going to round to the nearest tenth to find this here. So B is 7.9. Any questions on how we found the value B? Now, there are different, have a good one. We can manipulate these equations to find the angles. Now, one of the ways we can do it is actually plug in now the values of A, B, and C and solve for the missing angles. But if we actually manipulate this equation, we can get that B is equal to cosine inverse of A squared plus C squared minus B squared over 2AC. Or that for angle A is equal to cosine inverse of B squared plus C squared minus A squared over 2BC. Yes. Where C is equal to cosine inverse of A squared plus B squared minus C squared over 2AB. And these here would just give us the angle. And all we really did to get to this is really manipulate the equation, the general equation itself, to get the angle by itself. And all of these here, the angle that we're looking for, side length opposite is the one being subtracted. So if we're looking for angle A, the side length opposite A is the one that's being subtracted on top, and it doesn't appear on bottom. For B, it's the same thing. B is the side length being subtracted, and it's not on bottom. And the same thing is true with C. Because the side angle that we're finding, the side length that is opposite is going to be subtracted, and it's not on bottom. So, using this here and looking back at this figure, which angle do we want to find first? C. Well, angle C is equal to cosine inverse of our a squared plus b squared minus c squared over 2ab. Now this is where a and b's values actually make a difference because we need to make sure that we have them in the correct order. A in this case is 11. So we're saying 11 squared plus b is what? 7.9 squared minus our over 2 times 11 times 7.9. Well, guess what we can do at this point? Plug it in. So second cosine fraction of our 11 squared plus 7.9 squared minus 14 squared over 2 times 7.9 times 11. And if we're going to the nearest tenth, this would be 94.2. Questions on this here? So that tells us angle C is 2 degrees. So the last thing we need to do is find the measure of A. Yes. Because we can add 34 and 94.2 together and subtract it from 180. We could have done the exact same thing we did to find C to find A, and we would get the same thing. I think it'd be a little bit easier to take 34 plus 94.2, add those together, and get 128, and subtract 128.2 from 180. I believe we get 51.8 degrees. And that's it. That's all we have to do for this here. So, with this here, we found that the measure of angle A is 51.8. The measure of angle C is 94.2, and B is 7.9. And that's all we have to do for this here. Questions on this? Do we like this better than law of law of sines? But that's all we're having to do for this here. Any questions? Do we need to see another example with two sides and an angle? Yes, that's fine. Let's look at another one. So when we look at this one here, we're going to need to find the side length B and A and C. We're needing to find the one side and then the two angles. Now, since the side length is missing is opposite B, we're going to be using the equation B squared is equal to A squared plus C squared minus 2AC cosine of angle B, because that's the equation that we're going to use for this one here. That's going to tell us that B squared is equal to 43 squared plus 45 squared minus 2 times 43 times 45 cosine of our angle, which is 88. Any questions on this here? Now what we need to do to get b by itself is to square root both sides. And if we square root both sides, it'll tell us that b will equal to the square root of 43 squared plus 45 squared minus 2 times 43 times 45 times cosine of 88. And again, at this point here, we can type this whole thing into the calculator, and it will give us our answer. And we should get 61.14, which to the nearest tenth would be 1. Any questions on this here? Now, since 61.1 is definitely the biggest side, yes? Well, that means the other two angles have to be less than 88. Any questions on this before we find the next angle, or first angle? No? Do you mind if I erase this here for the work for B? Okay. Take 2. There we go. Now we need to determine if we want to find the measure of angle C first or the angle A. Because we're going to have to find both, but which one do we want to find first? C. Now C is going to equal cosine inverse of A squared plus B squared minus C squared over 2AB. Now A, we found, or know, is 45. So we have 45 squared. Plus, well, B is the value we just found of 61.1. Plus 61.1 squared minus C squared is our 43. All over 2 times 45 times 61.1. And at this point here, we can type it all into the calculator. Say cosine inverse of 45 squared plus 61.1 squared minus 43 squared over 2 times 45 times 61.1. And we should get that C is 44.69 or 44.7. Any questions on this here? Well, last but not least, last thing we need to do is, well, find the last angle, and we can find it by adding the two angles we know together and then subtracting it from 180. So 44.7 plus 88. 2, 132. And if we subtract 132.7 from 180, exactly 3, which gives us a 374. 47.3. And that's it. That's all we have to do for this here. Any other questions on these here? We ready for the other type? Well, the other type is if we're given 3 side lengths. So we need to find 3 angles. But realistically, how many angles do I really need to use an equation to solve for? 2. Because if I have 2, well, I know all 3 add up to be 180. So I need at least 2. So looking at this here, A, B, and C, which 2 do we want to find? B and C. Because it really doesn't matter which 2 we find, as long as we find 2 of them. There we go. So we can find B, and B is going to be cosine inverse of a squared plus c squared minus b squared over 2ac. And I think you said C or A? C. And C is going to be our cosine inverse of a squared plus b squared minus c squared over 2ab. Well, now we just need to plug the values in and type it into the calculator. So for B is going to equal cosine inverse of, well, our value of A, side length A in this case is 12. So we'd have 12 squared. Now C is our 20 squared minus 27 squared over 2 times 12 times 20. And well, at this point here, once we plug in those values for A, B, and C in their corresponding places, we can type it into the calculator. And if we type this into the calculator, we would get, let's see, squared plus 20 squared minus 27 squared all over times 12 times 20. 112.7 because we get 6/6, so it would round up to 7. So the measure of angle B is 112.7. Now to find the measure of angle C, well, that would be cosine inverse of, well, we said A is already 12 squared, plus B is 27 squared minus 20 squared over 2 times 12 times 27. So really we're switching out the 20 and 27, flipping their spots, and typing that in. 27 is becoming positive, and the 20 became negative. And we typed this in the calculator. I believe we should get 43.1. So C is 43.1 degrees. So now we're just missing angle A. Any questions on how we found the measure of angle B or C? Well, to find the measure of angle A, C's here. Try it again. We just need to add them together. So we can add 43.1 plus 112.7, 8, 5, 5, 1, and subtract 155.8 from 180, 2, 4, 2. And we should get 24.2 degrees. So we found that the measure of angle A is 24.2 degrees. Measure of angle B is 112.7 degrees. And the measure of angle C is 43.1 degrees. And that's it. That's all we have to do for these here. Questions on this? Any other questions on these here? Really, if 3 sides is just using the formula twice and plugging it in, it's actually a little bit easier than if we're given 2 sides and an angle. And that's it.